Good afternoon. Welcome to my laboratory. What you're looking at there is the display screen from my new old digital oscilloscope. This is the Link Instruments DSO 2102m screen. And I'm going to take the camera out of the tripod right now, so excuse the bumpiness. So there's the oscilloscope itself, tucked nicely under my instrument rack, and it's a parallel port device. The cable comes out and plugs into the back of my trusty dusty old ThinkPad 600E, which is the only computer I have left that has a parallel port. Okay, and so that's running on that. And so this video is going to be a demonstration of this oscilloscope, showing some of its features, and to use as a device under test. We'll be looking at the Ainslie circuit, the old the little Brian version here with one Q2 and one Q1. A couple of 5 ohm wire wound load resistors, and we're just looking at, I just taped them together and taped the thermocouple in there, and then this is the temperature of the load in degrees centigrade from the Fluke 83 with the Exotech temperature adapter in degrees centigrade there, and then this is the inline DC ammeter on the 200 milliamp range, and it is in circuit. Here are the 3 batteries, and here's the schematic we'll be using. Okay, so just now I have the system hooked up as in the old normal Ainslie mode, with current viewing resistor probe across the old shunt, which I've actually replaced with a 0.51 ohm resistor because I needed to match the one that I'm going to use for the new shunt in value, and everything else is wired just as Ainslie used in the June 29th demonstration, as shown on the diagram. Okay, so that's the setup for now, and I'll be changing that for the second part of the demonstration in a little while. Okay, now I'm going to put the camera back on the tripod, and I'm going to try to operate the scope and talk at the same time. And if you think that's easy, you've never done it. Okay, you see that all right? Alright, so first of all, we have, of course, your trace display area, but let's start at the top up here. So this is the version of the software that we're running here, DSO 2102 version 2B. It's the latest version that I could find on the Link Instruments site. Okay, and then at the top we have a button bar that gives us a save. Let's see here. This is a lot of information on this screen. So this is your save icon. This is plus or minus zoom, plus or minus sample rate. The auto set button, always nice. Stop and go, end acquisition, trigger mode, trigger channel. I keep forgetting what that one is. Oh, I think that's clear the buffer and refresh the screen or something like that. And then these are quick cursor positioning buttons. And then here's a nice print screen button. Of course, I don't have a printer hooked up. Okay, so that's the top row. And then here is this is the number of triggering events since reset, and then here's the current date and time. Okay, and then below that you see the time-based setting. So right now we are looking at 5 megasamples per second, and we have 200 nanoseconds per sample, right? And then we have the time per division on the screen of 200 microseconds per division. And then here's our zoom factor. Okay. And then over to the right of that we have the trigger parameters. Right now I'm triggering on the external input. And then over here is some cursor positions and information about that. These are more cursor positioning things, memory channels. And then over here are the measurements between cursors A and B. I can either measure across the whole screen or between cursors. So here's what we're looking at right now: gate duty cycle, gate frequency of pulsation, and then the maximum gate signal right here. We don't have anything on the CSR trace yet. Okay. And then over here are the channel settings along here. So we have gate drive and CSR voltage, 10x attenuated probe, DC coupled, the offsets are indicated, the volts per division, and then the cursor positions with respect to each channel there. Okay, so that's one of the really nice things about a digital oscilloscope, is that it has cursors foiled again. It has cursors that tell you what you need to know. Okay, so now what I'm going to be doing now is using the controls on the F43 function generator to turn up the gate drive until we get oscillations in the Q2s. Okay, but first I want to show you what's going on the screen here. Alright, so the channel baseline markers are these little symbols right here. Okay. That's the symbol for the channel baseline marker. And so you can see that I'm actually a little bit below the zero line there, and we have some negative going on. Up here the channel baseline marker is right there, right there. It's buried by the trace. Okay. And we have some cursors. This red cursor right here is indicating the trigger point. I'm triggering on the external input, so it doesn't have a corresponding horizontal level cursor. It's just triggering right there on the gate drive channel. Then we have the horizontal cursors, this green one and this blue one. I want to have that blue one set at exactly 4 volts with respect to the blue gate drive channel. Right there, 4 volts from the baseline. Okay, and that's pretty much all I want to do with the horizontal cursors. And then we have the vertical cursors here and here. These are the A and B vertical cursors, and so those determine the area that's being sampled for the measurements, right? Between cursors A and B for the time measurements, and then between cursors A and B for the voltage measurements would be between these cursors here. Okay, got all that? Alright, so now I'm going to go ahead and turn up the gate drive here till we start getting some oscillations. but I'm going to leave the maximum gate drive a little bit below that 4 volts. And if you want to see what the maximum gate drive is now, you can look up here, right there. So 3.6 volts is where we're at with the gate drive maximum right now. Right. So now what I'm going to do is, I want you to look at this area right here, which is the Q2, or rather Q1 on. And as I raise the gate voltage, you can see that trace starting to lift there, and when we get up to 4 volts on the gate, we have a significant lift showing current in the Q2, or the Q1 there, right? And if I look over at these guys over here, I'm going to turn down the oscillations so that we get a good reading on this instrument. Look at that. Notice that with the oscillations on, I get a false reading on the thermometer. So I have to turn the oscillations off to get a good reading on that Q2 there, or on the load reading. Okay, so now what I'm going to do is put the gate drive to about 5 volts right there, and of course that gives us a significant amount of current in the Q1 right in there. Okay, and now I'm going to turn that down again to stop the oscillations, and you can see that we had a significant temperature rise in the load from just that short pulse of current there. Alright. Now, one of the really nice things about a digital oscilloscope is that you can change the setup very easily by using stored setup. Okay, so I've got some stored setups in there, and if I go to, where am I here? 5. So I want to get 5. So let's load, quick load settings. 5. Quick load settings 5 there. Okay, so just like that, now I've loaded a preset set of settings, and what this is a zoom into the Q1 on time zone. Alright, so once again I have the cursor set at 4 volts right there, and then as you can see that as soon as we get approaching that 4 volts, see there, below 4 volts, we have absolutely no current in the Q1. But then as I increase the gate, you can see that substantial current in Q1 start coming up. Alright? And I think I might even have, let's see here, if I go to measure, edit measurements. Okay, a measurement 5, which is the maximum of the CSR trace between the cursors. I have an alarm set, beep on fail. Okay, so between the cursors here, now here I have the cursors set just encompassing the Q1 time, right? So when we get this trace going over 0, we should hear the alarm. Let's see if that actually happens. No? What did I do wrong? Let's see. Oh, 5. Ah, there it is. Okay. Okay, hear that clicking? So that clicking is the alarm that comes on when the voltage here between these two cursors on this yellow trace lifts above 0. You hear that alarm. Okay, so there's definitely current flowing in the Q1 when you get even a little bit below 4 volts on the gate drive, right? Okay, now I'm going to load another. I haven't done any changes to the circuit or to the function generator except to vary the amplitude. That's all I'm doing with this set. So now I'm going to load another stored setup on the scope, and this one is going to be the zoom on the oscillation. Okay, so I think that's 4. Let's see. Quick load. 4. Oscilloscope is supposed to be running here. Okay, so now there we go. So there's the gate and the CSR oscillations.